Okay, I think we can start. Welcome to Los Angeles Data Platform. Good time of the day, everyone, wherever you are. By the way, please drop your city and your country into the chat so we know which communities we are serving. Thank you for joining us today. My name is Steve, and I'll be host and moderator of this virtual meeting. I'll be joined by Yelena, and Yelena will take care of the raffle. And Yelena is part of the user group, part of the nonprofit, part of the SQL Server in LA. If you're joining us for the first time, or you've been with us before, and you would like to know which meetings to attend, here's a full list of, you can subscribe on Eventbrite or Meetup, or you can send us an email as well. So again, please visit our event or Meetup or Meetup pages to get notified on any upcoming events. If you're trying to see more than Eventbrite, you can follow us on various social media platforms. Most of the time we have video recorded and it's published on YouTube and Rumble. You can find more connections points through Facebook and Twitter, so you can follow us this way. I think that would be it for the social media. You can also join our mailing list, and you can just scan that QR code, and you'll be subscribing to our weekly newsletters and also notification on upcoming events. And this event is sponsored by Data-Driven Technologies, as well as Microsoft and SolarWinds. Data-Driven Technologies is a nonprofit that funds monthly user group meetings. Also funds our once-a-year event called SQL Server in Los Angeles, or as we call it now, Data SQL Server LA. And we are offering a t-shirt every user group meeting. So scan the QR code or click on that tiny URL link. It will take you to a form. You can fill out the details, and at the end of the user group meeting, we'll raffle a t-shirt. There are a couple of conditions. One, it's too much expensive for us to ship it outside of US. And as much as this t-shirt has a color, we will have actually limited colors now. During this presentation, if you have any questions, please wait until the end, and Dan is going to answer those questions. Without further ado, let's move to the rockstar of today's online meeting. Dan, please take it away and introduce yourself.
Thank you. Hi, everybody. My name's Dan Kane. We'll be talking today about Datalakes design, the shift from ETL to ELT, and modernizing your data wrangling approaches. And Steve, I don't know, can they see my slide deck? I need to share it. Let me go ahead and share my screen.
No, we still see the presenter. Sorry, yeah, Steve.
Here we go.
Yep.
See it now.
Yep.
Perfect. So a little bit about myself. I've been doing this for over a decade at this point now. I've held a lead architecture role on numerous projects. I currently work at 3 Cloud Solutions, a solutions director. My main focus is really modernizing, making sure that we have modernized approaches, and all of our go-to-market templates follow a certain follow the Microsoft guidelines, things of that nature, and making sure that when we do that, our IPs and things of that nature are built to make our go-to-market faster and stronger and more reliable. Outside of this, my hobbies are outdoor sports. I like to golf, fish, things of that nature, and I love family. So today's actually my dad's birthday, so happy birthday, Dad, if you're watching. And the last thing to note is that I really enjoy being able to impart knowledge to others, because that's the only way that we get started, and that's how we grow, is by sharing knowledge with each other. And then I hold multiple Microsoft certifications, and definitely looking to get some more here in the near future. The agenda today is really to go over the design shift, because Microsoft has really made a shift in the way design approaches are. We started with ETL process and we moved to ELT. On-prem systems, as technology grew and data volume grew, they had to start looking at how do we actually get data in faster, more consistently. How do we make the accuracy of our data better? Then we'll talk about tools and designs. So I have a few demos. We'll go through ADF, we'll go through Databricks, we'll do some Synapse analytics, and then last but not least, Power Query. And towards the end, after we get through that, I'll give you guys just some tidbits about data lakes versus data swamps and data lake design practices. So the design shift as a whole, as Microsoft grew, it really came down to 4 bullets, right? It came down to data volume, whether organizations chose to stay on-prem or move to the cloud. And then, does that historical approach still work for you, or do you need to move to a modernized approach? And then the tools that are out there. Some of there's questions around some of the new tools that are out there, and there's a lot of professionals that are comfortable in the tools that they used on-prem. So it was SSIS. Maybe you used a third-party tool like Talend, or maybe you just wrote a lot of T-SQL scripts to actually moving into using more like Python, notebooks, SQL Server, still using stored procedures, but ADF, data flows, things of that nature. Gartner has been pretty much telling us that our data was going to grow, and it was going to grow fast, and that big data was going to become the next best thing, and that we should be prepared for it as technologists. If you see here and you take a look at the chart on the left, the companies that really are using big data, there are a lot of them are talking about predictive models and using those in production. So you have 2 different type of model types. You have predictive and you have prescriptive. Prescriptive is your traditional data warehouse, where predictive is where you start building models to predict where businesses are going and how to utilize your data, to the data that's out there, to maybe open up a new store somewhere, or maybe you need to open up a warehouse on a different coast so that you can lower shipping costs or something of that nature. So that's where you see a lot of people talking about like predictive models and moving those into like production workloads. And then deep learning and neural networks, that's more of the machine learning aspect of it. There's different types of deep learning. There's you have your deep learning that's trained, and then you have your unsupervised deep learning, to where some of those learning patterns, are actually learned over time by events that happen within your data. And then as technology trends up, we have IoT devices and things of that nature. I can tell you for sure myself, when I go golfing, I use my Apple Watch, and that's just an IoT device that's capturing data 24/7, and all that data is being shipped somewhere. So how is that data being, how's it being wrangled? How's it being modernized? And how's it being valuable to organizations? And then you have cloud technologies, and the cloud technologies is really that trend to where organizations are moving more towards using cloud technologies and really paying for that PaaS or SaaS type infrastructure setup. And then you have the automation of business decisions. So businesses are being able to identify critical pieces or critical events that are occurring within their business a lot faster and automate making decisions. Sometimes there's even like the robot process automation and things of that nature that's really off of understanding what their data is telling them. And then Gartner also told us, over the next years, they're expecting in 2025 that data volumes would trend to 175 zettabytes. So as data is really trending up, Microsoft has already said that you would see that shift. And it's happening as they exactly said. Like, we're really shifting all the way up this curve. And truthfully, if you were to run these statistics again, we're actually starting to shift up a little bit more than even these predictions actually said in the beginning. So one of the biggest things that organizations always say, they ask the question, why can't I just stay on-prem? Why should I take cloud into consideration? Well, the main questions that I asked when I sit down with an organization is, do you understand the size of your data? How much would your data footprint grow over time? Because if your footprint's going to grow, you have only a few options, right? There's either you're going to scale out and you're going to buy more servers and make them the same size, because now that you have taken that one server and made it a monster, any server that you come up and stand beside it to scale out, you're going to need to stand it up at an equivalent size. And then sometimes a lot of organizations, especially like the government, they don't necessarily look at cloud as much because of compliances and things of that nature. But Microsoft and cloud providers have been getting a lot better at making sure that they meet those compliance needs. And then I just talked about scaling up and scaling out. Well, how much does that really cost? Do you really want to look at CapEx or OpEx? Does that shift in dollar amount mean something to the business? A lot of businesses can have a better write-off for the OpEx versus the CapEx. And then the last question is technology shift, and does the organization have the right resources in place? So taking a step back and actually looking at what the design pattern looked like historically. Historically, you had your OLTP systems, you staged your data, and then it loaded to your data warehouse to where you started reporting off of it with data marks and files and things of that nature. The tool that was truly used for this over time was SSIS. SSIS, which was truly like really introduced in like 05. They had DTS packages in 2000, but then DTSX with SSIS really got robust in 2005 and forward. And when SSIS came around, it became this tool that everybody was looking to really utilize the different using the control flow and data flows inside the control flow to really shift data around, wrangle it, move it to where they needed to, and massage it in a way to answer business questions and things that were needed, build reports, build things that they would use with the C-level folks to be able to like make better business decisions. So with that approach, Microsoft's first move was, okay, how can we do like a lift and shift and give something kind of similar in the cloud? And that's where they came out with Data Factory. And Data Factory V1 was the first Data Factory that was out, and then V2 came out. V2 was a lot more robust because it gave you data flows, but each V1 and V2 followed a pattern, right? The pattern was taking your data from source systems, using a linked service, parameterizing your data set, then copying your data somewhere, parameterizing the source, the destination data set, and then having a link server to land it. So in this exact setup, the way it landed, it was pretty much the same exact thing that Microsoft had pointed out with their on-prem systems, because at the end of the day, you're still landing your data right here in a SQL database. So now Microsoft is like, okay, our databases might not be able to handle the true amount of data that's going to be coming in. So as data volumes grew, Microsoft said, okay, step back. We need to modernize this approach. This is an exact replica of what we had people do, is an exact replica of what we had organizations do on-prem, but what's the next step? That's where the modern design patterns came into place. And this is directly from Microsoft's site. They then implemented Synapse. And when they implemented Synapse, they then turned around and they implemented like the data lake storage. And then you had a way to model and serve your data to eventually report off of it. So taking a step back again, let's look at what that looks like, right? So here's the historical. First thing that they did was take and you extract it. So this is your ETL process. You extracted your data from multiple different sources. Then you took SSIS or whatever tool of choice that you were using at that point, whether it was Talent or stored procedures with ODBC connectors and link servers or whatever you used then, and then you would load it to a staging or ODS. So they called that like their operational data store. And then after they transformed the data and everything within their ODS, then they would load it. And now you're loading it to your traditional data warehouse with multiple data marks that reported off of it, or even files and things of that nature. So historically looking back, this is what Microsoft called their ELT process, or I'm sorry, ETL process, which was extract, transform your data, massage it around in some type of way, and then load it. So Microsoft then said, okay, well, can we actually can the traditional ETL process continue to work with larger data? And taking a look at that and looking at how it worked, you started to lose a lot of time and just doing a lot of transformations of data, and it didn't open the door for you to do like streaming data sets or utilize a bunch of different unstructured sources, APIs, and things of that nature, and truly bring data in and actually just land it to then transform it how you need. And that's where Microsoft, if we start to break down the modern design pattern, the modern design pattern was built so that we can actually take that data and we would take and extract it using Synapse, ADF, Databricks, any of the new modern tools that gave you compression with like Parquet files or Avro files or anything of that nature. You would ingest the data, and then they said, hold on, let's step back. We're not going to transform it yet. Let's just load it. So the idea was to load the data into what was considered, the first pass of it was actually just blob storage. After they loaded it to blob storage, they turned around and said, okay, we have it loaded to blob storage and things of that nature. We can transform and things like that. But how do we get the right file structure for our data? How do we make sure that our data is, we can look at incrementally loading that data? What do we need? So that's where Azure Data Lake Storage V1 came into place. And then after V1, Azure Data Lake Storage came with V2. V2 came with like the hierarchical namespaces, things of that nature. It gave you the ability to use like Databricks or Databricks with like Delta tables and things like that, so that you still had your asset transactionality. So now that you still have asset transactionality, you have the ability to do incremental loads and look at your data and see your data as it is formed and as it comes in incrementally, and you actually have the ability to go back to a point in time and actually take a look at that data and see what changed or how to transform it or just to make different manipulations. Now, the big winner of this wasn't just the data engineers. The big winner of this was also your data scientists and things of that nature, because data scientists wanted to take all of the data from various sources in its absolute rawest format, maybe have some mashup of data and things of that nature, and be able to take all that data and start to make like predictive analysis and things like that off of it. So data scientists really looked at the data lake and they won in a way, because now if you look at the modern approach, a lot of data scientists and things like that actually report directly off the data lake. And in that data lake, Microsoft has what they call a bronze, a silver, and a gold. So your bronze is like your most rawest, your silver is like that mashup that your data scientists actually like utilize the most, and then you have your gold. And then your gold section is really like your curated, which you're going to send out and model for your modeling and serving. But Microsoft said, okay, we have all of that. Now we're going to use a series of tools, which is like your Synapse Analytics, your Lakehouse architecture, your Databricks, your ADF, your data flows, things of that nature. They're going to use a series of tools, and then they're going to transform that data so that you can actually model it the way that you need to give you the business a single source of truth in one universal space. So with that being said, we're going to get ready to start moving into some demos and things of that nature. And we're going to look at Databricks. We're going to look at just moving your data through like ADF and copy activities and things of that nature, and being able to parameterize some of that stuff. And then we're going to also look at another approach, which was recently introduced within the last year, which was the Power Query option that was introduced directly to be used in ADF and Synapse Analytics, because Synapse Analytics, their pipelines and ADF is somewhat the same, but there's some differences between the two. And then we'll look at like the Spark engine and the SQL pool and things of that nature, and we'll look at approaches through each one of those and how you can truly take your data and wrangle it and massage it and get it through that modern approach to where you want your data to sit. So with that being said, I'm going to close down the slides for now. There's a couple more slides, but we're going to go ahead and get ready to get started with the demos. Switch. Share. And can you guys all see this window? Perfect. All right, so I'll actually start outside of here. And we'll start with actually the resource group. And we'll just talk about some of these tools that we have in here. So Data Factory V2 is the orchestration tool that we're going to use today. Then we have our storage account, which if we take a look at the storage account itself, you can see here that we have the hierarchical namespaces enabled. The hierarchical namespaces gives you the ability to have those folder structures that I was talking about, and I'll actually depict those folder structures more later on to just talk about the difference between like a data lake versus a data swamp and why it's kind of important. Stepping back, we'll use Synapse Analytics, which you'll see here, and we'll talk about the SQL pools. We'll take a look at the ability to integrate your data lake structure and how we can add additional tables in here. We'll talk about the lake database and why Microsoft brought that into place. And then we'll also, I'm using the community edition of Databricks, and I'm connecting to my local machine, and I'm bringing data through, I'm connecting to my storage account, and I'm bringing data through here, and we'll walk through this sample notebook that I'll also leave for you guys, or leave it with Steve, or make it available for you guys to have access to, even if like I'll make it available through my GitHub or something of that nature. So getting started, the first process is really here in Data Factory. Data Factory, basically what we're doing here is using pipelines, and we're being able to take data and bring it in from my local computer, which we're using a self-hosted integration runtime. So this is where you can shift data from on-prem directly to the cloud. And you can kind of see here that I have a self-hosted runtime that is connected directly to my local box here that I'm using. And here's what the integration runtime looks like to show that I'm actually connecting to my computer and bringing data off of a SQL server and up. So what happens here inside of ADF, the discard changes. The first thing that we do here is we call basically a master package. And this is where we were looking at how things are parameterized. We're looking at like our audit job and our task workers, and which for me is just a way of controlling how data is moved throughout the environment. And then here, I'm actually basically saying, hey, what is my source system? I'm looking at a standard SQL Server source system that I'm ingesting data from today. And when we get in here, basically this is the ingest pattern to really ingest it through to land it into my data lake. Now, what happens here is we use, you can use a single pipeline really to ingest data and run multiple different copy activities at the same time. The benefit of doing that is you don't have to, back when we were creating SSIS packages, we had to create multiple SSIS packages. You could programmatically make them dynamic, but there was a lot more work to it. Data Factory kind of, Data Factory kind of took that away. They made it a little bit easier to parameterize things. They use JSON arrays. You can use like SQL tables and things of that nature to really control how data is loaded throughout, how data is actually loaded throughout your pipeline. So what I'm doing, and I'll show you the table here in a second, I'm going through and I'm controlling I have an ETL control table that comes through here. It sets like some parameters for me. It does a lookup using like a store procedure. And it gets some variables that I need. And once it gets the variables that I need, it plugs those variables into here, and it makes this copy task really dynamic, right? So if I was to take and kick off this master job here, you'll see when I open up the monitor, you'll see that a ton of jobs are going to start kicking off. So once it gets through processing that first, I'll instantly start looping through a ton of tables. And while that's moving and getting started, I'll bring up the SQL table so that you can see the different tasks that are out there that it's going to actually run against. And you can see here that I'm going to run against these tables, and I can set different type of limits on what I want, primary keys, things of that nature, to really get me to control my ETL. I've seen this done not just through like using a SQL database, but I've also seen it being completed through using like JSON files, because behind the scenes, ADF is truly a JSON template with parameters that are designed for each one of these processes to run. But you can see here, now I have multiple iterations running to copy data down through to my storage account within my data lake. And if anybody has questions and wants to know like more about like the internal workings of some of that, I have my contact information at the end of this, and I would be glad to like walk you through how to build something like this or anything of that nature. But stepping into the data lake storage account here, you'll be able to see that now if I start diving down into some of these tables, you can see right here that it's building like ETL date, and that date key right there saying like it's giving me like this 11/16, which is today. This is when this file was ran, and I can actually go pick up this file and look at my deltas or my changes, which this is in my raw. And as I start to move it to my transform, I'll actually just use like Databricks or something of that nature to merge it together. Why would I use Databricks in that process? Well, Databricks gives you the ability to have like delta tables, and delta tables give you the same asset transactionality as your traditional OLTP system. So you actually have the ability to merge data, you can delete data, you can update data, you can do, there's multiple different iterations of how you can take data and massage it and mash up and not lose transactions in transit. So it gives you the same functionality that your OLTP database gave you, but it's really sitting on a file system. This becomes beneficial because as you shift into like a big data architecture and your data is growing, you don't want to have a database that is massive and growing to where you can't really you're paying a ton of money for it, right? You want to be able to store your data as cheap as possible and still be able to access it, and that's what the whole modern approach gives you. It gives you the ability to have that data sitting on your data lake and not necessarily in a SQL server that needs license or anything of that nature, and still be able to go back and access that data. So that's really the first part of the process, is really taking that data and moving it across into that landing zone, which is our data lake. So next, once you get that data and it's kind of landed to your data lake, what's the next thing that you do? You start thinking about who has access to it, who does what with it. And typically when you're landing it to the raw, the only access controls that you give to that is basically the process that is bringing that data in and landing it to the raw, because you want to get it in its rawest format, and you don't want end users or developers or data scientists to be in there and inadvertently change the data in its rawest format. So that's where that raw folder structure comes into play. Like it's you have access controls and restrictions around it to where it's the rawest format that it is. And at any point in time, if you truly really need to reload, you can pull directly back from that raw system, because each one of these tools that are out there gives you the ability to process nested folders and things of that nature. So while that process is running, we'll step into like the Databricks portion of this, and we'll talk a little bit about the notebook. So now I'm using Python, and you can actually use SQL in here and things of that nature. Python, Databricks gives you the ability to use Python, R, in some capacity, Spark, and SQL. So as you're using these tools to query your data, I'll step through this notebook and show you what I did to actually be able to stand up what we would call like that lake house architecture foundation. So wrangling what my data does here is now I'm using like the Delta tables and things of that nature. So the first thing I'm doing is I'm looking to see, I'm saying, hey, create my database if it doesn't exist. I'm calling it AdventureWorks. And taking a look here, you can see that now I have a database called AdventureWorks. And I'm gonna delete this so that we can recreate the table. So it creates my AdventureWorks database. This is really the foundation of creating your lakehouse, because this database gives you the ability to use either to copy into, or it gives you the ability to use live tables, which gives you streaming options and things like that from different type of IoT devices, and use like autoload or something like that. And I'll step through that here shortly. But what this does is it creates the database. Now I want to list my files that are within my database, well, within my file structure, and I'm making a connection out. And I'm not going to show you guys this up here because these are actually my credentials to connect to. But that's the reason I'm doing that is because I'm in a community edition. If you're implementing something like this in prod, you should use scopes. And Azure Databricks gives you the ability to define scopes and use Azure Key Vault to get those security, those keys to connect. Databricks also has a second way of storing keys, and it's basically Databricks has like a scope, an internal scope housing mechanism. It's almost like it's their own internal database that they use to where it stores the keys as well. It's kind of almost like on like a Hadoop type file system or something of that nature. But the key takeaway here is being able to take and use scopes to address making your connections out to like your storage account. So the next step that I'm doing here is I'm listing my files. So this tells me when I run this, it says, okay, in the path that I'm at right now, I'm down to this folder right here. Here is the file that is actually in there. So if I took this out right here and ran this again, it's going to tell me that now I have 3 different files that exist, 3 different folder paths, should I say, that exist. And I could choose any one of those folder paths to navigate in later on down here. But this is almost like your command line list command, giving you the ability to say, hey, go down to this folder structure and tell me what's out there. So an important piece that I don't want to forget here is this ABFSS here. This is really the naming convention that you give to Databricks to say, hey, I'm connecting to my data lake. I'm connecting out to Azure, my Azure data lake storage. But again, looking down into this location now is telling me that this is the Parquet file that I have out there. So here I'm appending that Parquet file to this entire connection string and loading my actual data that's there to a data frame. Once I load it to the data frame, if you're familiar with Databricks, you can then start. I'm sorry. This is actually set my variable. This is setting my sales order details variable, saying that my sales order details variable equals this storage location. This right here is declaring my data frame, and then I'm using the Spark read format of Parquet. I'm inferring my schema, and then I'm saying that first my header row is true, so it's telling me that my first row is my headers, and I'm loading it from the variable that I defined up here. Great. So now that that's done, just something, a tidbit of knowledge for you guys. Inferring your schema, sometimes it's good to do it from like your files. It gives you the ability to do like schema drift and things of that nature. But if you step outside of the box and look at bigger environments that have data, a lot of like nested JSON files or something of that nature, sometimes you actually have to define your schema to make it run faster. You're going to look at defining your schema and then looking at partitioning your data. And that's a little bit more advanced for the conversation today. I'm just kind of really walking through the data wrangling techniques, but just something to think about is if you ever run into where you're inferring your schema, it's using, basically what it's doing is using a series of files, and it's looking at what the schemas look like across those files, and it's inferring what the schema should be there. But that doesn't necessarily mean that that is truly the answer to the schema. And that's why I'm telling you, you may have to think about actually defining your schema in certain cases. And it actually, if you, you can get a performance gain out of being able to define your schema as well. So kind of what we're doing right here and what we've done is we took ADF as an orchestration tool, not Databricks, but we took ADF and we loaded the data here. And now we're taking Azure Databricks, or in the next part of the demo, we'll look at the Spark cluster. We're taking either one of those and we're prepping the data and training it to move it along to like your silver or your gold. So now that I took the data and loaded it to a data frame here, all I'm doing is display my data frame, and this is showing you the data that's out there. Here, what I do next, this gives me a way of like really looking at it in memory. I'm looking at the data in memory, and I'm trying to determine like what do I want to do with it. The next thing that I do here is, okay, now that I've looked at the data, I've validated what I wanted to see, I'm going to create my table. And this is creating my sales order table, and this is where you get your Delta Lake table. So this is the foundation of your lakehouse architecture, is having those tables. So now it recreated that table that we just deleted. And you can see it here, it's back. And here I'm saying, okay, now that I know what data I have up here, maybe I really only want a series of elements out of that table. So I'm taking all my products, some in my quantity, and some in my order details to build myself an aggregate table. So in some case, there's a lot of cases where organizations, they want like that. When you build a data warehouse or something of that nature, you want to go to the lowest grain, but you also want to be able to roll that data up to some type of a aggregation. And there's cases where you don't need to take all that data farther downstream. This is where like having Delta or the Spark engine or something of that nature, this whole lakehouse architecture works to our favor when it comes to big data analytics. So what I'm doing here, again, is that I'm aggregating it and I'm kind of like visualizing what that data would look like, where I can get some type of a visual of what I'm going to do whenever I get ready to visually represent that data to the business. Does my numbers look right? Is there something missing? I would hate to get all the way to the reporting aspect and didn't have any way of actually like validating what I'm expecting. So Databricks really has become a strong tool to be able to do a lot of that under one hood. And kind of what I was explaining before, there's two data ingestion patterns to consider when choosing how to like incrementally load your data. Autoloader, heavily recommended for like streaming data sets and things of that nature. And there's some Microsoft documentation here that you'll be able to just click on the link and go to it. And also autoloader usage with Delta Live tables. Delta Live tables, Delta Live tables is really where you have like that streaming ingestion. Autoloader can technically be used for batch and incremental, but the copy into is going to probably be your better process. And then there's going to be a link here to give you the ability to look at some of Microsoft practices and patterns with the copy into. So this is the Databricks pattern for ingesting data and massaging it and things of that nature. The next area that we're going to step into is we're going to step into Synapse, because Synapse gives you a similar approach. So now with Synapse, I've actually taken and built like my Lakehouse demo database here, and I've loaded a table and it's inferred to schema. But think about legacy data modeling techniques and things like that. Now that you did that, what about bringing in another table and how does it relate to this or something of that nature? Well, the good thing with Synapse has built its own version of the Lakehouse architecture, which gives you the ability to build the same thing that Databricks has built, but now keeping everything under the hood of Microsoft. So when I say keeping everything under the hood, just so that you know, like you can do all your ingestion, you can analyze and explore, and you can visualize your data all under just Synapse Analytics. So stepping back, I have this script out here that actually connects to that table, the Lakehouse demo table. And you can see that it's actually using the built-in serverless SQL pool. And the data lake table is really just a pointer, right? All it is a pointer. It's pointing to the file system. So how's that a pointer? I'll show you how that's just a pointer and it's pointing to the file system. Let's go here. And let's act like we want to bring in another table, or let's actually just let's actually open this up and bring in another table. So we'll bring in this sales header table. And we're going to use the link service that I have out there. And it's just going to tell me to browse to the table that I want. So let's go with sales order header. It's going to detect your schema. It'll ask you, it'll take a look at the data. You can preview your data here if you want it. Let me see. And then once you preview your data, you can select create. And this probably wasn't the greatest table to bring in. But once I refresh this, gotta publish it first. Now, once I refresh this, you'll see that I have that sales order header table. I didn't refresh this side. So I have my sales order table here. And if you want to then query that, let's see, refresh. I can say, just give me my top 100. And the same type of select statement that you're used to seeing. And now I'm connected directly to my data lake tables. My data lake files, these connected directly to the Parquet files. Now this probably should have brought in a different table, because then I could show you how you can actually take and build relationships directly within this Lakehouse database as well. So let me see. Data lake. Let's see if I can show you guys how to create the relationships. So I brought that one in, Let's try this one. All right, so now that table should be sales order. Okay, perfect. Because we look at these two tables now. We can then go in here and define a relationship between the two tables. And this one be sales order ID, sales order details. And then the column, sales order ID. So now we're defining relationships like we would define a model. It's there. There you go. We're defining the relationships like you would define a model directly in like your Synapse workspace or something of that nature, but you're doing it directly on your lakehouse. You're doing it on your data lake. So now when you're bringing you're wrangling your data in, you're actually being able to model it from a graphical interface versus figuring out how to join it here in your data frames and things of that nature. So pretty cool feature that Synapse brought to the table, giving you that lakehouse database and giving you the ability to take the lakehouse and make relationships between the two. You see that it shows that it's the foreign key, and you can query. We could publish it and then query the two tables together, do joins or whatever the case may be, and those references, it shows how the referential integrity between the two. So before we step out of here and step back into the last portion of the demo, I just wanted to briefly talk about the fact that you also have the ability to build like notebooks. And the one caveat to building notebooks is, for some reason, you have to put in a support request and for Microsoft to actually increase your core count, because the Spark pool is going to request what it thinks it needs to run that. Oh, yep. Okay. Your job requested 40 vCores, however, the workspace only has 12. By default, just so that you guys are aware, any environment that is set to a certain core count. You can put a request into Microsoft to increase your core count. And they pretty much, as long as you request it within a certain amount, they pretty much always just auto approve it. But they set it at a minimum, and you could probably Google it and see it yourself that it's something that's known, that's out there, and things of that nature. The last data wrangling technique that I'm going to show you guys and massaging data is actually stepping back into ADF and talking about Power Query and data flows. Data flows and Power Query both, just so that you know, use the Spark engine. It's not heavily adopted, but it's very good for somebody that's a novice and don't know how to like utilize a lot of the tools and build some of the dynamic stuff that's out there. The reason why it's not as heavily adopted is because there's a cost factor with it. If you look at any of the pipelines that you run, it all comes down to the cost. And if I go back here to the Azure Monitor and we just look at like one of the copy activities that occurred, you can see like there's so much data that was read, how many rows we read, and how many files that it wrote. But the big caveat to this is, what some don't know is, if you go dive down into this, your parallel copies, and you know how you try to go on Azure Calculator and kind of get like something close to how much something costs you to run or something of that nature. Really, you can look down here and look at like how many parallel copies, your duration. You can look at the different parameters that is going to be plugged into here, and that's how they actually come down with the estimate. when you look at data flows and you look at Power Query, it actually has to stand up a Spark engine. And when it stands up that Spark engine, you're paying for that compute, and for each task and for everything that it has to call down in there, it comes with an additional cost. And that's why like data flows are really hard, and data flows and Power Query is really hard to understand or pull out the actual cost estimates, but they're a lot more expensive and harder to like troubleshoot and things of that nature, especially if you don't have it like fully baked out. But I'm just telling you guys that because from a cost perspective, I've found every option that I've talked about so far to be the cheaper, more efficient way to move and wrangle your data within your data lake. So real quick, just to show you, and then I'm also going to show you something that you'll run into trying to pull directly from your data lake into a Power Query. So we should get an error message that comes up here. Yes. Okay. So the reason why this starts off, you see that it's the Power Query Spark runtime, so it's standing up a Spark engine like I was telling you. This starts off because when you drill down into your ADF location and you drill directly to that Parquet file, this undefined right here, that undefined doesn't give you the direct location on the file system that you're trying to go to. So what I found that you have to do is, you can see here under Parquet 1, I connected to Storage Explorer and actually gave it the full path for what I was trying to pull in. Once I did that, then I was able to go in and start doing the manipulation on the data the way I wanted to. And you can see here, just like you see in Power BI, it'll show you your applied steps. So you can see here, at first I removed columns that I didn't need. And then I did my grouping logic, the same thing that we did in Databricks, same thing that we did in Synapse Analytics with queries, but now I'm just doing it more with the graphical user interface that you would see in Power BI. I'm actually just taking the data, grouping it by, taking a subset of data and building my aggregates, because I'm taking the products, the total sales, quantity, and I'm doing that as my transformation. And as I take it out of my transformation, I'm just taking a pipeline here. And in my pipeline, I have my settings to call that notebook where you see the user query and it pulls up what it's calling. And then basically my sync, where I want it to sync to. But here you can see that it's going to be standing up a Spark engine. So if you want to if you're trying to stay away from standing up a Spark engine, Power Query, data flows probably aren't the best. But if you have big data and you're trying to like true big data, and you're trying to massage data at faster speeds, then that's where that Spark engine is going to get you your bang for your buck. All right, so let's see. So as I stepped through, we was talking about like the lake house architecture and the data lakes and how data is landed. Some key concepts that I want to like kind of leave you guys with before I open it up for questions and things of that nature is, you're starting at there's a lot of security around this, and you want to make sure that you have a true data lake, and you don't want a data swamp, and you want to restrict access to who has access to what. So throughout your resource group, it comes into your storage account, your file system, and then you have your folders in your file layer. In your raw, this is where I was saying that you're gonna have access restricted. This is where only your process is connecting to, pretty much nothing else. As you transform, move your data over to your silver or your transient, that's where your developers, engineers, and scientists, that's where a lot of them are going to come into play and really want to query that data, massage your data, do maybe some predictive analytics off of it. And then as you move it to your goal layer doesn't have to be in the folder structure. It could be in Synapse, it could be SQL database, it can be in the folder structure. All depends on the size of your data and what you're trying to do. But this is your curated, this is your goal layer. This is where your developer, engineers, data scientists, end users, this is the champion data set for everybody. This is from a high level architecture. This is like your bronze, silver, gold, raw, transformed, curated, whatever type of language you want to put around it. And then you use like your network security groups and things like that to apply who has access to what. And then lastly, but not least, with the Delta Lake, you're being able to just recapping that you have the Delta tables and you have the asset transactionality, but then making sure that you're organizing your hierarchy or folder layout. These are some examples of some things how I've laid it out for organizations in the past, where in my raw, I've dropped down to like whoever the files are coming from, what's the file format. You might have in here, if I had insurance type up here for this case, but you might have later on down the line what department it's for or what entity. So like if it's from Salesforce, it might be your customers table, it might be your accounts. And then you break it down to year, month, day. And sometimes even if you might go down to the hour. Depends on how transactional, how frequent you have data coming in. Transformed really brings all of it together. Parquet, transactions, who it's coming from, Parquet, year, month, day. You may be merging transactions from multiple places together and building pretty much like one big structure, and then sorting it out to your goal, to where you're breaking it out to maybe you want your enterprise to see everything, but maybe you have role-based access controls to where maybe your East Division only has access to one side, or your West Division has access to just their data. You can build your rollback access controls and things of that nature there. So there was a lot. So I'll open up the floor to any questions that you guys may have, feedback, things of that nature. I definitely like feedback as well, just so I can get better at giving presentations.
Please feel free to unmute yourself, ask questions.
I'll ask. So I'm not using Azure. I'm working in GCP or AWS. So I'm trying to kind of draw parallels and understand, how to apply maybe some of the ideas. And one of the issues I have been running into is, like I know you talked about the Delta Lake and the, bronze, gold, and silver layers and all of that. Like I have an OLTP database, and we were considering using Click Replicate to get the data into our data lake, because we want to be able to kind of like pick up only, the newest transactions, not everything. There are millions and millions of rows, and we don't want to be trying to feed everything every day and then trying to sort out after we landed it in the cloud what we need and what we don't need. So what's the best way to do the delta on retrieval?
So the one good thing is Databricks is universal across the board. Databricks is open source, and Delta is just sits on top of it. Or I'm sorry, Delta is open source and it sits on top of Databricks. Databricks is compatible with AWS, GCP, all cloud platforms. So you literally can actually take some of these practices and design patterns that I just ironed out with when I walked through like the Databricks notebooks and ingest it directly into like AWS and use it.
Okay.
And on AWS, you're going to have your S3 buckets, and then you're going to take your S3 buckets, and then you have the Redshift and the Redshift Spectrum engine for AWS. So Redshift Spectrum is pretty much almost like that lakehouse architecture because now you're reading directly from files, where Redshift is more like the Synapse SQL pools.
Yeah, actually, AWS in that sense is easier. When I was working in AWS, I was using DMS and Glue to get the deltas and then create the Parquet files and drop them into S3, and that was better in GCP. I'm still trying to figure this out.
Yeah, so you're right. You can do that with Glue and things of that nature, but the reason why I say Databricks is because it's easily portable, and you can't port that Glue. No, you can't port the Glue code out and ingest it into another system.
Okay, and you're gonna share your slides, right?
Yes.
Yeah, thank you.
Then you can either share it through your GitHub, and if not, you can send me the file, the slide deck, the code, and I can use our own data-driven technologies GitHub.
Okay.
A question for me that is more of a generic question: how much time it took you to go from SSIS to this?
So moving from SSIS to Data Factory, once they brought V2, was almost seamless because they had data flows. But then I realized that it was really costly and I wasn't doing things as efficient by using the data flows and needing like the Spark engine just to run simple ETL. So transitioning to Databricks and Python actually was a little bit harder. It took me a few months.
Got it. No, obviously, I'm not going to tell you anything new. It looks like if SSIS has a steep learning curve, that looks like it has multiple learning curves. Super steep.
I don't know. If you're comfortable with Python, then it's not bad. And if you like SQL, it's really understanding the Python portion to be able to at least get the notebook stood up and get it running to get to where you need to, because then you can switch over to the SQL, PySQL or Spark SQL, which you've seen in the notebook, where I just converted over to SQL, and now I was just running SQL select commands.
Got it. Still, again, there were too many moving pieces.
Yeah, but it's really the modernized approach. There is a lot of moving pieces. It's about picking which one you actually want to go with and sticking with it. Because I do see in a lot of organizations, and I'm actually working with an organization right now where they have multiple different tools, and truly you just want to find one and follow that same pattern.
Well, this session is recorded and will be published to YouTube and Rumble once it's all polished. Thank you everyone for joining our online meeting today. With that, thank you, have a great day, and see you here next time.
Thanks for having me.
Thank you, Dan. Thanks, everyone. Bye.
Bye-bye.